Hi, everybody. Today I want to talk to you about box plots. Box plots are kind of interesting, but not that important in my opinion. So let's learn a little bit about them. So box plots are the 5-number summary, essentially. So I'm not sure I ever defined what the 5-number summary was. So let's do that. 5-number. That's a P, not a B. Let's try that again. 5-number summary. So the 5-number summary is the minimum, call that the min, then Q1, then the median, then Q3, and the maximum. In order. It is literally those 5 numbers. So you have a data set, you find these 5 things. And remember that the median is the middle, it's the dividing line, and that divides your data into the left 50% and the right 50%. Q1 is the first quartile or the 25th percentile, which takes your data and divides it into the first 2 quarters, right? So it takes the left half of your data, or the smaller half of your data, and divides that into 2 further halves. Q3 does the same thing for the upper half. So this is, how can I describe this? These 3 numbers, Q1, the median, and Q3, divide your data into 4 equal pieces. I say equal pieces, I mean that there are the same number of data points in each piece. And then the minimum and maximum set the upper and lower bounds. So I have some data. Let's share that up. So where's go? So I've got some data here. This is I used this in a previous video. I don't remember exactly where this came from, but what I need is I need the median, Q1, Q3, minimum and maximum. All right, so here my minimum is 3.96, we'll call that 4. Maximum, let's say that's 36. So what I'm going to do is write those down. So my minimum is 4, my max is 36, and then we got 7 3/4, 10.2, and 13.2. Let's see how much of that I remember. This one. So we had this was 4. This was 7.75. This was 10.2. 13.2. One of those 0.2s isn't right. And this one was 40. Let me go briefly back to look at my data. Not that I care about being precise here. Median 10.2, Q3 13. No, I remember it all correctly. Great. Okay. So here is what a box plot is. It's the graphical version of this. It's literally just 5 dots on a number line, essentially. Now, we don't draw them as 5 dots on a number line. Somebody decided to get fancy and make a box out of it that has arms on, but that's really what we're doing here. So I've got my number line here, and I want to emphasize when you are making a box plot, you must have a number line first, because otherwise, all the meaning behind the box plot is lost. I'll explain what I mean in just a second. So minimum is 4. So here's 5. So 4 is like there, right? A little bit less than 5. 7 3/4 is a little bit more than halfway between 5 and 10. So 5 to 10. So halfway is there. So we're going to have that, something like that. 10.2, it was my median. So it's just barely bigger than 10. That's close enough. 13.2, a little bit more than halfway from 10 to 15. So like here. And then 40 is way over there. Okay. So I've got 5 lines. I got 5 vertical lines. And here's what I'm going to do. I'm going to make a box out of these middle ones. I have some arms that go to the outside ones. That is a box plot. Box plots have, what they do is, well, remember that this is being divided up into 4 pieces. So if you think of our data as this line here, right? Our data is a bunch of dots interspersed along that line. A quarter of the dots are between 4 and 7 3/4. So here, a quarter of the dots are between 7 3/4 and 10.2. and a quarter of the dots are between 10.2 and 13.2. And then a quarter of the dots are between 13.2 and 40. So you might say to yourself, well, Jeff, that doesn't look like those are each equal quarters, and they're not. Space-wise, they are not equal. However, when we go look at our data, let me go back to the data. You might notice that most of the points are between 7 3/4 and 13.2, right? This one between those two, between the two. This one's a little less than 7 3/4, so it's in the smaller quarter. This is in the middle 50%, the middle 50%. This one's a little above 13.2, right? But the bulk of our points are between. In fact, let me do this. Let me quickly make a histogram to show you what I mean. So you can see the points are not equally interspersed along the x-axis, right? There's a lot of them in here and not all that many up here or down here. So a quarter of them are between, what do we say, 3 and 3, or between 4 and 7.75. So a quarter of them are like between here and here. Then another quarter of them are between here and like there. Then another quarter of them are between here and here. And then the last quarter of them are between here and all the way up at the top. And that's what a box plot's showing. Now, here's why box plots are useful. Some people like to display their data in box plots. I personally don't know why. I just use histograms all the time. But some people do like to display their data in box plot form. The reason I don't love box plots is that they are counterintuitive to read, in my opinion. And here's why. Quarter of the data is in here, quarters in here, quarters in here, and a quarter is in here. So what that means is the areas on the x-axis that are in very small sections of the box plot have the same amount of data as areas in big sections of the box plot. So the intuition is a little bit backwards. The small portions have just as much data as the big portions. So what that means is the data is very dense in these small portions. Like there's a lot of, there's the same amount of points in here and in here. So same amount of points in smaller area means they're very dense. Like there's just as many in here as there are here. And over here, they're very sparse. As you can see, that's what our histogram looks like, right? Very dense in this region, right? The bars are really tall. Very sparse over here, where the bars are really short. And so to me, that reads a little bit backwards, right? It's counterintuitive to think, okay, small area in the box plot means tall area of the histogram. And that is essentially what that means. But that's what a box plot is. That's really all there is to it. I don't want to say too much more about them because I'm not going to use them very often. I'm going to use histograms a lot because to me, those read a lot easier and they also go a lot better with what we're going to do in topic 4. And in fact, in every topic thereafter. Yeah. So that's what box plots are. Sometimes what people will do with their box plots is instead, like you can see, there's going to be outliers over here, right? So if we use the 1.5 IQR method, like if you've watched the video on outliers, you'll know that there are definitely outliers here because this 39.96 is an actual point in our data set. And the IQR only went from 7 3/4 up to 13.2, which is about what, 5 or 6. So 1.5 times that far. Here, let me use the same color I did in that other video. 1.5 times that far is only going to be about, here, right? So everything above this inner fence is an outlier, right? And you might say, oh, there's tons of stuff there. Not necessarily. There might be a few things in there. Or there are definitely at least a couple things in here, but there don't necessarily have to be tons of them because again, the data is very sparse in this long area. So what some people will do is they will split those out instead of having the arm go all the way up to 40. They might cut it off at the inner fence and then just put a few dots. Right. So instead of having an arm here, they would have like a dot for each of the outliers. And you can see that in your calculator. I'll show you how to make a box plot in the calculator. In fact, let me go ahead and do that right now. I'm going to go ahead and pause the video here and get the calculator up. All right, so let me show you how to do all this on your calculator and also in Excel, and very specifically not in Sheets, and I'll show you why. So here's your calculator. I've put in some random data, so you can see I have, well, it's not exactly random, but I put in a bunch of data points. Right, so I've got them all on my list, and oh, if you've forgotten how to get here, it's stat and edit. Right, so the stat button and then the first option gets you to the lists. And so I put a bunch of data into L1, right? So this is where you put things if you want to do anything with your data. So from here, I'm going to quit out of there and show you how to make different graphs. So we're just talking box plots right now, but I'll show you how to make some other ones too while we're there because they're in the same place. So I'm going to go to stat plot, which is the second function of y equals. And so I've got plot 1, plot 2, plot 3. So basically we have 3 different plots that we can do at the same time. There are six different graphs we can make. So let's I'm going to hit enter here on plot 1. They're all the same. It's just there's 3 of the same thing. So there are 6 graphs we can make. This one, this one, this one, this one, this one, and this one. So you may have used this one before. This is called a scatter plot. It just plots points on a graph. So right, if you wanted to plot the point 3, 2, you could put that in here and it would graph it. Just normal XY algebra point graphing. This is the exact same thing, except it connects the dots. So I guess that's not true. I think for this one, you might have to have successive x's. Maybe you can't use the same x. I don't know. I don't know exactly. These are basically the same. I never use this one. This is a histogram. They're really useful. I love histograms. We're going to talk a lot more about them in the histogram video, which you may have watched already. The histograms in your calculator are not very adjustable. They're not great. The histograms on a computer, like in Excel or in Sheets, are much, much better. I would strongly recommend using them. So these two are box plots. And this one is a QQ plot. Don't worry about that for now. We'll actually use this one quite a bit later, but these two are the ones I'm talking about right now. And if you remember, I said that some people like to split out their outliers as dots. So I'll show you that one in just a second. But let's show you this one first. So I'm going to turn plot 1 into this one. This is a box plot, or this is just what's called a basic box plot. Hit enter on that. I'm going to want my lists to be L1, because that's where I put my data. And once I've got that, I'm going to quit out of here. So second quit, let's get back to the blank screen. Data is still in there. Plot 1 is still selected. Let me show you where you go to tell the computer or tell the calculator to actually graph plot 1. So like if I hit graph, for instance, right now, you'll see that we don't see anything. In fact, let's zoom back to the standard place, right? So this is probably what you'll see if you just hit graph. The reason is anything that you want to graph has to be turned on in y equals. So this is your list of things that you want to graph. And you notice we've got plot 1, plot 2, plot 3 up here. So, and we had plot 1, plot 2, plot 3, and stat plot. So I made, let's just remind ourselves, I changed plot 1 to be a box plot. Plot 2 and plot 3 are both scatter plots. We're not going to do those right now. So when I go to y equals, I want to go up to plot 1 and turn it on by hitting enter, and that highlights it. And so now the calculator knows to graph plot 1. And when I went to stat plot, I told it what kind of graph I wanted and where it could find the data. So when I hit graph now, what happens is we get a box plot. Now you can't really see it because it's in the wrong area of the windows in the wrong area. So what you want to do is a really, really common thing that we're going to have to do a lot if you use the calculator a lot, which is zoom. So you can zoom in and out and move around if you want to, but there's a way better way. If you're making a graph from stats or from using data, the thing you want is number 9 here, zoom stat. All right, so I'm just going to hit the 9 key. You can scroll down and hit enter if you want. I'm just going to hit 9. And what it will do is it will zoom. It will set the window so that all of your graph is nicely centered up. It's great. I love that zoom function. The zoom functions, by the way, in the TI 83 and 84 are awkward. They're not great, except for this one. This one's great. Works really well for graphs. So there you go. You can see that I've got this long right arm, which if we go, let's go look at the data for a second. I deliberately have an outlier here, right? So 32 it's an outlier. So 32 is the maximum, and that's why the right arm is so long, is the next highest value is 14. And I actually don't know what Q3 is, but it's probably between 11 and 14. So that's why we get this long right arm, because Q3 is 11 to 14 or whatever, and then this max is 32. So when I don't have it split the outliers out, remember, when I go look at this, I chose the one that just had the arms, no dots. If instead I were to choose the one with dots, what it's going to do is, well, let's hit graph and see what it looks like. Now it puts the maximum at the outer fence, or actually it puts the maximum at the highest non-outlier value, excuse me. So the highest non-outlier value here is 14. And then it splits out the outlier into its own little dot. So here we've got like the bulk of the data plus its own little dot. Right. So here, one thing that you can do is I'm going to hit trace. And what it's going to do, I'm going to hit left and right here, and it's going to move from minimum, Q1, median, Q3, maximum. So this is the highest non-outlier value, and then over to the outlier, right? So it doesn't call it the max. Notice that all these others, right? It says that the minimum is 1, Q1 is 3, median's 5, Q3 is 11, and then it doesn't call this the max because it's not, right? It's just the highest non-outlier value, and there's the actual maximum. So there you go. That's how your calculator makes box plots. So let me get back to whiteboard here. And I want to show you how to make a box plot in Excel. So, oh yeah, sorry, let me get rid of the chart and start over from the beginning. So this is the tree height data. Actually, I think this is the tree height data from your homework. So let's make a box plot of tree E. So I'm going to highlight this, and let's see, where's charts? So I'm going to insert charts. Now, if I go to the recommended charts, Boxplot is not in here. So I have to go to all charts. And this is another reason why I'm not crazy about Boxplots. I don't, like most people, don't use them that much. It's called box and whisker plots. So let's make that. I'll hit OK. And there's the chart. And we can give it a title if we want to. I'm not that interested. So here's what we've got. Now, instead of making it sideways, it's making it vertical, but it's the same idea, right? And you can see, it's a little hard to see here, but it's got the dots split out. If I mouse over these, yeah, it'll show us here. Tree E.1 value 7.76. Oh, interesting. The first value. No. Oh, when they say value 1.1, they mean the first one, or they mean the smallest one. 0.1 value. I don't know what 0.1 means. Anyway, one thing that you can do that's nice in Excel, I believe, is that we can do this. Let's make 5 box plots. If I go to charts, recommended charts, and then just choose all charts, we want box and whisker plots. Yeah. It will make us comparative box plots, which are actually pretty nice. Right, so now we can have all 5 of our trees, all 5 of our tree types on the same plot, which is nice. It lets us compare them, right? You can see that this is the smallest kind, this is the next smallest kind, this is here's the biggest kind, tree A is the biggest kind, etc. So we can actually see, we can compare them to each other really easily, which is fantastic. That's one thing that Excel does really well. Now, I mentioned that I'm not going to show you how to do this in Sheets and I'm not because it's awful. I like sheets a lot in general, but they have a weird blind spot when it comes to box plots. They don't have them. You have to do it manually. Like if you go look for a box plot in here, you will not find one because Sheets does not have weight. Candlestick chart. Is that not the same thing? Yeah, it's not. I don't know why, but they don't have a box plot function. This is not that. I know the picture looks like it, but it's not. They don't have a box plot function. And one of the ways I know this is I spent a lot of time looking up how to make box plots in Sheets, and you can't. You have to do it manually. You have to find the minimum, Q1, Q3, median, and maximum using these commands yourself. And then it is possible to kind of draw your own chart. I don't know why it's so hard, but they just have this giant blind spot. They just won't make box plots. So don't do it in Sheets. You can't. If you really want to make a box plot, then and you want to use a computer to do it, you're going to have to copy it into Excel and then use the Excel box plot chart maker. You can do it in SPSS also if you want to. As always with all of these things, I don't want to show you how to use SPSS because it's super complicated and messy. And if you really want to do it in SPSS, ask me how in office hours and I'll show you. But it's less easy. It's less easy than it is in Excel. It's way easier in Excel. So yeah, so here's the thing. Here's the way I'm going to test box plots on the test. So I think there's some value in having you make things by hand. Okay, this is going to be a bit of a tangent. You guys may have seen Bloom's taxonomy, which is a pyramid. In fact, let me. I'm gonna pause for a second and go find that because I wasn't planning on talking about this in here, but I will. So let me come back in a second. All right, let me show you Bloom's taxonomy. So here is Bloom's taxonomy. It is a teaching and learning, not exactly system, but a framework to think about teaching and learning. So here's the idea. This, by the way, is not like, don't think of this as literally true, and I'll tell you why in just a second. But basically, these are, the idea is that these go up in complexity as you go up the pyramid. I don't know why it's a pyramid. So remembering things is sort of the lowest level of learning, right? Someone tells you something, you remember it, spit it back. Understanding is the next level up. Not only do you remember, but you also understand why that thing exists the way it does. From there, once you understand what it is and remember it, then can you apply it to some real world situation? Once you can apply, understand, and remember, can you analyze someone else's application of it, right? So not only are you applying, but you're analyzing another application, deciding whether that application is good or bad, what went right or wrong, etc. Evaluating is pretty similar to analyzing. As you can see, justify a standard decision here. So I don't want to go too much into, like, evaluate and analyze to me are very similar. Create, you have to not only do all of this stuff, but then make your own thing. And so in some sense, this is thought to be like the highest, most complex sort of thing that you can do. And that's basic, that's kind of true. And so you might think to yourself, well, the natural thing to do is to work your way up the pyramid, right? First you remember something, and then you understand that thing, and then you try to apply that thing, you try to evaluate or analyze somebody else's application of it, and then you try to create your own. That seems like a natural progression, but in actual fact, one thing that works really well to help you learn things is if you try and create them right from the beginning, even without full understanding. Because when you're trying to create something, you have to do all the stuff underneath it, right? Most specifically, to create something, you have to remember what it is and understand why it is the way it is. You can actually kind of skip these bits for creating. And so the reason I tell you all this, the reason I have this huge digression here, is that the way I'm going to test specifically boxplots is I'm going to have you make them by hand, because it's going to force you to do a few things. One, it's going to force you to put them on a graph. So let me go back here. Remember how I said you have to start with your number line? The reason you have to start with your number line, and let me show you what people do wrong with box plots when they're making them. So what do we have? 4, 7.75. All right. So very often on a test, I will say, make a box plot out of this data, right? Either you have to find the 5 number somewhere, or I'll just give it to you, and then make a box plot out of it. And what a lot of people will do is this. They'll say, oh, okay, so I should have 4 and 7.75 and 10.2 and 13.2 and 40. And then they'll label them 4, 7.75, 10.2, 13.2, and 40. This box plot is totally worthless. It has no value whatsoever, because literally the entire point of a box plot is to see the shape. And to see the shape, things that are farther apart have to be visually farther apart. So this 13.2 and this 40 are a long way apart. So you can tell the data is really sparse in here. When I did this, you can't tell that at all, right? This box plot has no value whatsoever. Don't do that. And so I want to force people to think about what their box plot is trying to represent, sort of as a broader goal of forcing you to think about what graphs are representing in general. So the way I'm going to have you make the way I'm going to test box plots on test is by asking you to make one. Right? I want to use the top end of Bloom's taxonomy here to force you to understand, to do the bottom parts of Bloom's taxonomy. And by the way, just heads up, if you can remember and understand, you will get A's in basically all of your classes, right? If you remember the information and understand why it is the way it is, you're going to get an A, pretty much. And that's certainly true in my class. And it's true in almost all of your classes, at least until you get to like grad school. If you can create your own new original works, that's fantastic, right? That's top end thinking, but that's like senior project kind of stuff. Just remember and understand it. You're probably good to go. So I am going to ask you to create a box plot to force you to remember and understand what you're doing. Remember what goes into a box plot and why it goes in, right? So that's my plan. So that's how I'm going to test them. So yeah, make sure you know how to make them. And the way you make them is you find the 5 number summary, minimum, Q1, median, Q3, maximum. And by the way, in case you are ever not sure what goes into the 5 number summary, well, your calculator, TI-80, TI-83 and 84 will do it for you automatically. If you remember the one variable stats function, right? So stat calc one variable stats. If I find one variable stats of L1 and scroll down to the bottom, it literally gives me the 5 number summary, minimum, Q1, median, Q3, maximum. It's great. Super handy. And those are the things that go on your box plot too. So there you go. Yeah. So that's super helpful. But basically what I'm trying to get at here rather slowly is that the way I'm going to test box plots is I'll have you make them. So know how to make them and know why you need an axis and why it needs to be evenly spaced. Do not do this. This has no value. It is a list of numbers. This is just the 5-number summary. I understand that there's a box drawn above it. This is not a box plot because this does not show the shape, which is literally the entire point. So yeah, draw your number line first, then put your 5-number summary on that, and then connect up your box arms. Okay, that was a bit of a rant. That was more of a rant than I was intending. I'm sure that there will be a chapter on the YouTube video that says titled Rant. Yeah. And I think that's all I want to say about Boxplots. I'll go ahead and stop the video here, and I will see you guys in the next one.